In this video, we're simply going to do two pretty easy examples involving present value of the annuity. The first one is the same setup as our, I believe, first problem in the previous video. Suppose you invest in an annuity with periodic payments of $2,000 annually, once per year, for 10 years. The interest rate is 6% compounded annually. Find the present value of that annuity. Well, I've written out one of the forms of the formula, and in the second example we'll use the other form. Either one is good as they're equivalent. Let's notice that R, remember capital R always represents the amount of the periodic payments. So for us, for this problem, R is 2,000. I is not the annual interest rate, but the interest rate per time period. But because the time period is annually, then I is the same as the interest rate. Technically, this should be the interest rate over the number of payments per year, but the number of payments per year is just 1. And the interest rate is 0.06, so I is 0.06. And N, similarly, N is not the number of years, it's the number of payments that are going to be made. But the number of years is, there's only one payment per year. So once per year for 10 years, normally this would be the number of years, T is 10, the number of years, time. Normally it's T times M, but as we mentioned earlier, M is just a 1, and T is 10, so the number of payments is 10. The periodic interest rate is 0.06. The periodic payments are 2,000. That's all we need to figure out what P is. We have all of the variables necessary on the right-hand side. So let's write this out. Maybe I'll just continue it right here. This, P, is equal to this. Well, the R is 2,000 times, in brackets, the numerator is 1 plus I. That would be 1.06. 1.06 raised to the n power, which is 10, minus 1, all over. I is 0.06 times 1.06 to the 10th. Now, don't be tempted, I hope you're not, I hope you remember your arithmetic. You can't cancel these two because in the top, it's not 1.06 to the 10th times something, it's this minus that. So you can't cancel those two things. Don't make that simple mistake. All right, well, if you plug this in to a calculator, you're going to get 14720 and 2 cents. So now, what is that telling us again? What is it that the present value of the annuity means? Well, it means if somebody puts $2,000 a year away for 10 years, and the interest rate is 6%, the amount of money that person's going to have at the end, which I think we computed that in the earlier video, how much was it? It was over $20,000 because the contributions there are $20,000. It was, I don't remember what it was, but the point is you could have that exact same amount if instead of putting $2,000 per year, you simply make this one single payment at year number 1 of $14,720.02. So you're putting this all in at once, where the other person is putting in $2,000 a year for 10 years. So you'll notice this person's putting in $20,000 in his own principal, but this is one lump sum payment at the very beginning, and you'd end up having exactly the same amount. So I guess here I just need to write again 14,720.02. Okay, so I guess I already mentioned this, but this tells us that one lump sum of this amount, 14,720.02 invested in the account one time, one lump sum, will accumulate the same amount 10 years later as investing $2,000 annually, once per year, for 10 years. Number 3. This one we're going to use this present value, the second present value formula. So determine the present value of the following annuity. Periodic payments are $4,000 annually for 8 years. So once again, annually means we're just going to have 8 payments. So this is our periodic payment. 8 years means that T is going to be an 8, which means also N is going to be an 8, the total number of payments. Interest is 0.07, compounded annually, so that's going to be not only R, but it's also I, 0.07. And we simply plug it in. So for this, the present value of that, and before we do it, I want to ask you a question just to think about. How much money is going in for 8 years? $4,000 annually. So this person is putting in a total of $32,000. So at the end, it's going to be worth much more than that. How much do you think this one-time lump sum payment is going to be to equal the same amount at the end of the 8 years? Is it more or less than $32,000? Well, hopefully you know that it's less than that, because all of this money put in up front is going to gain interest for the entire 8 years, where in this situation, only the first $4,000 gets interest for the entire 8 years. Then the next one is one less, and then one less, and so on. So let's write this out. P is equal to, R is 4,000. Now I'll do the denominator first. It's 0.07. This would be 1 minus 1 plus 0.07 is 1.07, raised to the negative, don't forget that negative sign, N, which is 8. And if you plug that into the calculator, you get 23,885 and 52 cents. So that would be the one lump sum payment. In other words, it's the present value of the annuity we described right here.